Hello everyone, in this video we'll be studying about the classification of gear trains, and also we'll be discussing in detail about the simple gear trains. So what are gear trains? So gear trains are simply a combination of two or more gears that are made to mesh with each other to transmit power from one shaft to another, and these are known as gear trains. And based on the arrangement of wheels, basically there are four types of gear trains are there, and we'll be seeing one by one. First one is simple gear trains, then we have compound gear trains, then we have reverted gear trains, and finally we have epicyclic gear trains. And we'll be discussing about all of these gear trains in detail in coming videos. And in this one, we'll be seeing what are simple gear trains. So if you're considering simple gear trains, you can understand from this animation. So two gears are in mesh and they are transmitting power. Simple gear train means the shaft which are carrying these gears. That means only one gear is coming on each shaft, and this power is being transmitted between this shaft through this gears. So these are the simple gear trains. So we will be studying some term called velocity ratio or speed ratio, and again train value for the simple gear train. So here you are having two gears which are in mesh. So this, if the left one is rotating in the clockwise direction, then this will be rotating in the anti-clockwise direction, and we will be calling this one as driver gear. Then this will be known as driven, and we have a quantity or term called that is known as velocity ratio between this, or for this simple gear train, that is known as velocity ratio, and we can call it as VR. And this velocity ratio is defined as the ratio speed of the driver to driven. Suppose the driver gear is this is known as driver. So suppose the driver gear is known as is rotating at omega 1 speed, and the speed of this driven is omega 2, and let the number of teeth on this driver is t1 and the number of teeth on driven is t2. Then the ratio of velocity of the driver omega 1 to driven omega 2, omega 1 by omega 2 is known as velocity ratio, and this can be related to the number of teeth as t2 divided by t1. So this is known as the velocity ratio for a simple gear train. And a similar quantity you can define for the gear trains, that is known as train value, and this train value is defined as simply the inverse of this velocity ratio, that is the speed of the driven to speed of the driver. Driven is also known as follower. So then we will be having, or we will be getting the train value for this simple gear train as omega 2 by omega 1, or it can be written also as t1 by t2. So this is the train value, or how you can obtain the velocity ratio for simple gear trains. Here we have another case where this is also a simple gear train, where the a shaft is carrying only one gear. So in this shaft only one gear is coming, here also only one gear, and here also only one gear. But here you can see this is also a simple gear train, where this in between this driver gear and this driven or follower, another gear is coming, and that is known as idlers, and we will be seeing why they are called as idlers. So for this gear train, for this simple gear train, we will be deriving or finding the velocity ratio. So let the speed is omega 1, omega 2 for this one, omega 3 for this one, and their respective directions of rotations are also shown. When the driver is rotating clockwise, the meshing gear, that is 2, will be rotating anti-clockwise, and finally this 3 will be rotating clockwise. So the number of teeth on this will maybe t1, t2 and t3. And by the term velocity ratio means the velocity ratio is simply the ratio of the angular velocity of driver, that is 1, to the driven, and driven is the final gear, which is 3. So omega 1 by omega 3 is the velocity ratio, and we will be finding the velocity ratio for this one. So if here gear 1 and 2 are in mesh, so you can calculate omega 1 by omega 2. Omega 1 by omega 2 can be related to number of teeth as t2 by t1. And similarly here gears 2 and 3 are in mesh, so you can calculate omega 2 by omega 3, and this will be equal to number of teeth t3 divided by t2. So you can calculate omega 1 by omega 3 by multiplying this omega 1 by omega 2 and omega 2 by omega 3. So if you are simplifying this one, this omega 2 and omega 2 will be getting cancelled, and finally you will be getting omega 1 by omega 3. And this can be equated to, this is equal to t2 by t1 is omega 1 by 2, and omega 2 by omega 3 can be written as t3 by t2. So here also finally this t2 and t2 will be getting cancelled, and finally you will be getting t3 divided by t1. Here if you are finding in the final expression for the velocity ratio, the number of teeth on the idler gear or the second gear is not coming. That means the T2 term is not having any influence on this velocity ratio. It is containing only the number of teeth on the driver 1 and the driven or follower gear T3. So these gears are not affecting the velocity ratio, but they are having influence only on the direction of rotation. And this type of gears are known as idlers. Here we will be seeing another case of simple gear train. Here between this can be considered as the this will be the driver gear and this final will be the driven gear. And if you are knowing the angular velocities of this as omega 1 and this is omega 4, and there are some intermediate gears whose velocities you can name it as omega 2, omega 3, and here velocity ratio means you have to calculate the ratio of angular velocity of driver omega 1 to omega 4, and let the number of teeth on these gears are T1, T2, T3 and T4. Here also we will be finally seeing the intermediate gears, that is 2 and 3 are not having any influence on the velocity ratio. So gears here gears 1 and 2 are coming in mesh, so you can find omega 1 by omega 2 as T1 T2 by T1, and similarly 2 and 3 are in mesh, so you can calculate omega 2 by omega 3 as T3 divided by T2, and 3 and 4 are in mesh, so you can calculate omega 3 by omega 4 as T4 divided by T3. So if you are multiplying all of this term, then finally you will be getting the velocity ratio, that is omega 1 by omega 4 can be found by this omega 1 by omega 2 into omega 2 divided by omega 3 into omega 3 divided by omega 4. That means these terms will be getting cancelled and finally you will be getting this omega 1 divided by omega 4. And this can be found if you are multiplying all the right hand sides, then this T2 and T2 will be getting cancelled and this T3 and T3 will be getting cancelled, and finally you will be getting this ratio as T4 by T1. So here also in the final expression for this is actually the velocity ratio, final expression for this velocity ratio, only the number of teeth on the driver 1 and driven is coming, that is simply omega 1 by omega 4 is T4 by T1. That means the number of teeth on the intermediate gears T2 and T3 are not having any influence. So here also those are known as idlers or idle gears. That means they are not having any influence on the velocity ratio. But if you are seeing, see this is rotating in clockwise direction, this is rotating in anti-clockwise direction, then 3 will be rotating in clockwise, and finally this is rotating in anti-clockwise. So here based on the number of idler gears, there is some condition for the relative sense of rotation between the input and output or the driver and driven gears that we will be seeing now. So idlers do not affect the velocity ratio, it only affects the sense of rotation between the driver and driven gears. So if you are seeing here the number of idler gears, this is known as idler gear. Here number of idler gears is 1 or this is odd. So when the number of idler gears are odd, here the sense of rotation between the driver and driven will be same rotation or like rotation they will be having. Here if you are seeing the number of idlers gears, see here 2 idlers are there, which is actually an even number. So when there is even number of idlers gears, then if you are seeing this is rotating clockwise, anti-clockwise, clockwise and anti-clockwise, so then they will be rotating in the opposite direction. So these are the idlers gears which are not affecting the velocity ratio, they only affect the sense of rotation. So this is all about the simple gear trains, and in the next video we will be seeing or we will be studying in detail about the compound gear trains. So thanks for watching.